Hey, I'm Leo Scheibe and my restoration project is on Murgoitio Park in Boise, Idaho. Murgoitio Park is an undeveloped 163-acre plot of land in southwest Boise. This picture here shows a master plan from 1997 of what the developed park would look like, which was obtained from the City of Boise Parks and Recreation website. The left side of the image sits along Maple Grove Road and the right side of the image lines up with Cole Road. According to the Friends of Murgoitio Park, this land was set aside in 1993 to one day be developed into a park for the community. Nearly 30 years later, it still remains untouched. And in 2021, Boise attempted to exchange the land with real estate developers before the community put a stop to that. This area is one of the largest open spaces remaining in Boise. While it is still utilized as an agricultural site, it has the potential to become both a beautiful park and conservation site. It should be restored for the biological well-being of native species, in addition to meeting the recreational needs of the community. For this project, 4 main restoration goals were identified: revegetation, habitat enhancement, landscape integration, and sustainability. This picture shows what the site looks like currently, with Cole Road pictured on the far left. Revegetation will be achieved by planting a variety of native species throughout the park. Habitat enhancement will be accomplished through the implementation of native species, water sources, and active management. Landscape integration will be implemented throughout the park with recreational trails, fields, and ponds. Sustainability will be achieved through active management by the city, ensuring the park is supporting the local biological and social needs. In 1994, Grumbine, a conservation scientist, noted that ecosystem management integrates ecological relationships within a complex socio-political framework toward the general goal of protecting native ecosystem integrity over the long term. Grumbine understood that for a project to be sustainable, its design needs to align with both the social and biological landscape. Murgoitio Park can meet both of those needs. According to the USDA's Ecological Site Description, this site is a part of Idaho's Snake River Plain, which is shown in orange in this image. This description reviews the historic conditions of Murgoitio Park. The Society for Ecological Restoration notes that historic conditions are the ideal starting point for restoration design. In this area, sunshine is higher than the U.S. average and about 10 inches of rainfall occurs annually, creating a semi-arid environment. Native vegetation within Murgoitio Park primarily includes grasses, then forbs and shrubs. Dominant species include blue bunch wheatgrass, Turber's needlegrass, and Wyoming sagebrush. The soil at this site is gravelly and deep with a loamy surface. It is made up of both sandstone and limestone. It features rapid permeability and drains quickly. Erosion risk is moderate at most, and runoff can vary from slow to high. To restore this site, 3 attributes of a restored ecosystem will be focused on. The first attribute would be a characteristic assemblage of species. Since this site has been farmland for over 30 years, it has lost its diversity. This attribute is the first of 9, as native species build the foundation for an ecosystem structure and function. Grasses, shrubs, and forbs are integral to this site and would be actively restored through seeding, planting, and continued maintenance. This 163-acre site molds into the greater landscape by providing habitat for a variety of wildlife. Large herbivores can forage, such as deer. Sensitive species such as the burrowing owl and the pygmy rabbit have the potential to utilize this site for their ongoing survival. Reestablishing native species would serve to aid the conservation of sagebrush, a reportedly trying conservation effort according to Riddle for KTVB. He spoke with Matt Germano, a research ecologist, about the problems facing sagebrush restoration. Germano stated that the landscape isn't responding in predicted ways to the treatment. So the criteria for this project would be to strongly establish a dominant species from each section: a grass, a shrub, and a forb. Restoring functional groups is a primary goal of this project. This attribute focuses on establishing groups like shrubs, forbs, nitrogen fixers, and pollinators. Dr. Foard shared a quote from Hildebrand et al. 2018 that the recovery of a function will become more likely if the composition recovers as well. Once native species are reestablished, functional groups will start to reform and strengthen into a strong ecosystem. Criteria for successfully establishing functional groups would be the increased presence of pollinators and herbivores, in addition to the long-term presence of native grasses, shrubs, and forbs at the site. This park would serve as a conservation site and recreational amenity for the public. The City of Boise recognizes the importance of open spaces for wellness and recreation, economic vibrancy, ecosystem health, cultural value, education, and for providing a sense of place for the community. Kevin Lynch, a city planner that focused on environmental connection, noted that the deepest meaning of any place is its sense of connection to human life and indeed to the whole web of living things, which is from 1960. The criteria for the site to be integrated into the landscape is the availability of walking paths and a conservation status established by the City of Boise. The main protocol for this site will be active restoration through surface applications, a term used to describe labor-intensive restoration according to Pike et al. Some species would be transplanted in to initiate the process, but focus will be on seeding treatments, which were found to be more effective in semi-arid climates by Rowe et al. Specifically, reseeding at various times of year increases chances of success. Since seeds will be the dominant tool in restoration at this site, Broadhurst et al. Notes that seed quality and locality are of utmost importance when purchasing seeds for a project. Local seeds are more likely to be adapted to unique environmental conditions at the site. Mortlock found that local seeds improved both survival rates and plant development. A key monitoring technique to be utilized is implementation monitoring. As described by Pike et al. In 2018, this strategy is about tracking a project's progress with a table and evaluating species present throughout project stages to ensure plans are being followed correctly. Pike et al. Also describes a protocol for collecting data at a site. By defining sampling units, which are plots within the park, progress can be tracked. Kyudon et al. Notes that the best sampling unit is long and thin, so each sampling unit would be 8 feet long and 2 feet wide with 1 plot per acre. Data will be collected from each unit twice annually, late spring and fall for 5 years, then the project will be reevaluated after that time period. Data includes noting the quantities of the 3 dominant species and the presence of other diverse species as well. Also, a photograph will be taken each time to track species evenness. This aligns with the density data collection protocols described by Kyudon et al. This table shows indicator species that will be monitored within sampling units. 3 indicator species will be focused on, each a dominant grass, shrub, or forb found in sagebrush steppe. Rangel describes this ecosystem to have consistent evenness, so each species is looking for an equal distribution at the site. The plus 10% is to show the presence of other species of shrubs, forbs, or grasses in the system, a good sign of increasing diversity in species composition. More monitoring time is allotted to sagebrush since they are notorious for taking extra long to recover, with Burrett et al. Noting complete sagebrush recovery taking between 20 and 100 years. With grasses and forbs showing a higher presence during that recovery time. While this project will take years, it is achievable with proper resources and thorough research. So, to walk you through the table, the first key species is a grass, blue bunch wheatgrass, and 23% of plants per plot should be this species. Another 10% represents other grasses that we want to be present. Data will be collected twice a year for 5 years for grasses and blue bunch wheatgrass. Next is a shrub, Wyoming big sagebrush, which should represent 23% of the plants, with 10% more being other shrubs. Sagebrush will be monitored biannually also, but for an extended period of 10 years. Last is the forb, arrowleaf balsam root. Same plant distribution as the others, with biannual monitoring for 5 years. This is page 1 of my resources. This is page 2 of my resources. Thank you for listening to my presentation on Murgoitio Park.